So last problem we solved the frequency response of a discrete time system. So this system is a continuous time system, and what we are looking for is the same is frequency response, impulse response, and the output given an input in time domain. So we are going through the same steps, and what we are going to do first is try to solve the Fourier transformation. Here is Fourier transformation because it's continuous time. The Fourier transformation of the input signal, and here the input signal is Ct. And we want to make it a little bit general, so we will have another C prime t equal to e2 minus alpha t ut, and we can just solve it by the definition of Fourier transformation. So the definition is xf equal to integral from minus infinity to infinity xt e to the power minus j to pi ft dt. And here c prime f equal to the integral. Because of the step function, the integral go from 0 to infinity e2 minus alpha t e2 minus j 2 pi f t dt. And we want to merge this t, so we have the integral from 0 to infinity e2 minus alpha minus j2 pi f t dt, and this is minus alpha minus j2 pi f, and the numerator is just 1, and the integral is solved by e2 minus alpha minus j2 pi f t, and t go from 0 to infinity, and the infinity part, because this negative sign goes from it will become e to negative infinity, which is 0 minus e to 0, so this will become 1 over minus alpha minus j2 pi f, and here is 0 minus 1, so this is 1 over alpha plus j2 pi f. So this is very important. We mark this pair down, so e minus alpha t ut, and the Fourier transformation is 1 over alpha plus j2 pi f. We're going to use it a lot. So here c, for signal ct, alpha is just 1, so ct is e2 minus t ut, and the Fourier transformation is just 1 over 1 plus j2 pi f. So the next thing is the frequency response, and same as before, hf is yf over xf. So we want to solve the Fourier transformation on both sides of the equation, and we have the property on cheat sheet is the because this derivative, so we have the derivative property is dx t dt has the Fourier transformation j2 pi f xf. So the first order derivative will have one multiplier here, so when we come to the second order here, we just have the multiplier cube. So on the left hand side is j2 pi f cube, square, yf plus 4 times j2 pi f yf plus 3yf. On left hand side is j2 pi f xf plus 2xf. And then we move yf and xf on the left hand side, so we have yf over xf equal to, on the top is the coefficient of x is j2 pi f plus 2, and on the bottom is the coefficient of y, so it is j2 pi f squared plus j2 pi f 4 times plus 3. So j2 pi f, we see it as one thing. So as we want to split this part, so we can use the inverse dt of t. So we want to simplify this a little bit. So this will become j2 pi f plus 1, j2 pi f plus 3. And the numerator keep the same as j2 pi f plus 2. And then let's split it. We are going to use the same trick as the previous problem. So we have this one equal to j2 pi f plus 1, and the numerator is a plus b over j2 pi f plus 3. And if we use the same trick, we're going to solve the equation set as, for the scalar, we have 3a plus b equal to, the scalar here is 2, and for the j2 pi f part, we have a plus b is, and the coefficient here is 1. So if we solve these two equations, the equation set, it will give us a equal to half and b equal to half. Then we have hf, which is, what we want is half 1 over j2 pi f plus 1 plus half 1 over j2 pi f plus 3. Then we want to solve the impulse response ht. So we want to use the pair we have derived in the first slide, the red one. So let's copy it here. So the pair is e2 minus alpha t ut has Fourier transformation 1 over alpha plus j2 pi f. So for the first term of hf, alpha is 1. So the first term inverse Fourier transformation of the first term is e minus t ut, and for the same reason the second term is half e2 minus alpha is 3, so 3t ut. So this is the impulse response. And then we want to solve the output. So the frequency domain output is yf equal to hf times xf. So if you try to plug in the result we have already have, j2 pi f plus 2, this is hf, j2 pi f plus 1 times j2 pi f plus 3 times 1 over j2 pi f plus 1, and here's already a plus 1 here, so this one square, and we can erase this part. This is not very easy to solve the dt of t, still because of this square term. You can still split it, but the inverse dt of t will become a little bit complex. So we are going to use convolution to solve it, and it will make things a little bit more easy to compute. So yt equal to ht convolute xt time domain xt. So as we already have solved ht and xt, this is ct. ht ct. So as we have already have solved ht, we can just plug in it. So it is half e2 minus t ut plus half e minus 3 t ut convolute e minus t ut. So by the linearity of convolution, we can do the first one and the second one. So A equal to half e minus t ut convolute e minus t ut and plus half e minus 3 t ut e minus t ut. So the first term equal to half, because we know that this convolution only non-zero when t is greater than 0, so we have a step function here ut, and in the non-zero part the integral goes from 0 to t, and the product of the signals e minus tau and e minus t minus tau d tau. Because this tau and this tau can cancel, so this integral is nothing about tau, so we can take it out and it will become a product. So it is half ut and e2 minus t, which is the inside thing, and times the range is t minus 0, so t minus 0 is just half t u t e minus 2 minus t. Okay, this is the first term. And the second term is, for the same reason, we have step function here, and the range is still from 0 to t, and the first signal is e minus 3 tau, and second term is e minus t minus tau d tau. And we can first take this minus t part out because it's nothing about tau, so this will become half ut e minus t, and the integral from 0 to t, and inside here is a minus 2 tau d tau, and the integral can compute as let's just first copy the things, 1 over minus 2 because of this minus 2, and inside here is e2 minus 2t minus e2 0 t, so it's just e2 minus 2 times 0, so it's just 1. And we can simplify this as and the scalars can combine into minus 4 and ut, and inside parentheses we have e2 minus 3t minus e2 minus t. And if we add these two terms together, which is the final answer is yt equal to, because they all have the ut as a common part, we take it out, which is ut times, first we have this half t e2 minus t, this first term, and then minus 1/4 e2 minus 3t, and plus 1/4 e2 minus t. So this is a time domain solution by convolution.